Today, our objective is to draw graphs from real-life situations to show the relationship between two variables. So here is a starter. We have a distance time graph shown. Imagine you are asked to describe the movement that is happening at points A, B, C, and D on the graph. What do each of the points represent? So this graph shows that at point A, 15 meters distance was traveled in the first 5 seconds, that's from 0 to 5 seconds. At point B, another 5 meters distance was traveled in the next 10 seconds, that's from 5 to 15 seconds. At point C, no distance at all was traveled for 5 seconds, that's why the line is flat. So from 15 to 20 seconds, no distance was traveled. And at point D, we have that the return journey started at 20 seconds and ended at 30 seconds. That's from 20 to 30 seconds. So we can use a distance time graph like this one here to describe a journey. The vertical axis shows the distance traveled, and the horizontal axis shows the time spent traveling. So let's take a look at the analysis of this graph. This graph shows that the starting point is 0, 0, that's at the origin, okay? And 100 kilometers was covered in the first 1 hour, between 9 a.m. to 10 a.m., all right? Also, we have that no distance at all was traveled for an hour between 10 a.m. to 11 a.m. That is why you see that the line is flat, okay? The journey continued 50 kilometers for half an hour between 11 a.m. and 11:30 a.m. And finally, we have that the return journey started at 11:30 a.m. and ended at 12:30 p.m. So at some point, you can be given the time distance coordinate. Here's the table of values that show the relationship between the time and distance, okay? So if you're asked to draw a graph using the time distance coordinates shown on this table, it's the same thing. The first point is showing the starting point, which is the point of origin, 0, 0. And the next point shows that a distance of 15 meters was covered in 5 seconds. Okay, that's the line. And the next one shows that a distance of 20 meters was covered in 15 seconds. Okay, and the next one shows that a distance of 20 meters was covered in 20 seconds. And finally, the last point shows that in the last 10 seconds, no distance was covered. I also need to remind you about the 3 formulas for speed, time, and distance. So you remember them from this triangle DST. So when you're asked to solve for the speed, you do speed equals distance over time when you're solving for speed. When you're solving for time, you do time equals distance divided by speed. And when you're solving for distance, you do distance equals speed multiplied by time. So we're going to be making use of these formulas to solve questions in this lesson. Let's take a look at example 1. I set off from home on a journey. I traveled 2 hours at an average speed of 60 kilometers per hour. I decided to stop for 30 minutes to pick a friend, then traveled back home at an average speed of 40 kilometers per hour. Draw a distance time graph of the journey. So the first thing we need to do is to find the key coordinates, because we're required to draw a distance time graph. So we need to get our coordinates, our distance time coordinates, in order for us to be able to draw the graph. However, we're given instruction as to how our graph should look like. I'm going to explain this in the next slide. So we need to work out the key coordinates, that is the time distance coordinate, so we can be able to draw our distance time graph. So how do we solve this question? Now the first line in the question says, I set off from home on a journey. So that is the starting point. And the starting point is represented by 0, 0. That is the point of origin. So our first coordinate, our first time distance coordinate is 0, 0. Then the second line says it traveled 2 hours at an average speed of 60 kilometers per hour. So we're given the time, we're also given the speed. So we need to get the distance. Remember that to find the distance, you do speed multiplied by time. The speed is 60 and the time is 2. So to calculate the distance, we do 60 multiplied by 2. That will give us 120 kilometers. So it means that it traveled 120 kilometers. So our second key coordinate will be 2 hours and 120 kilometers, where the 2 hours is the time and the 120 kilometers is the distance covered. Now the next line says it decided to stop for 30 minutes to pick up a friend in his car without covering any distance. So that's an extra half hour, because you need to convert 30 minutes to an hour. So converting 30 minutes will give you half hour. So you need to add the half hour to the previous 2 hours that was covered before. So that is 2 plus half. That will give you 2.5 hours. So the next key coordinate is 2.5 hours and 120 kilometers. Then finally, it traveled 120 kilometers home at 40 kilometers per hour. So it will take him time equals distance divided by speed. So to find the time, we do distance divided by speed. So the distance is 120 kilometers and the speed to travel back home is 40. So that's 120 divided by 40. That will give you 3 hours. So we need to find the total time taken for the journey. So the total time will be 3 plus 2.5. So that is 5.5 hours taken all together. So the time distance coordinate for the last one is 5.5 hours, 0, because no distance was covered as at the time he got home. So we need to take the coordinates gotten from our workings to plot the graph. So following the instruction given in the question, it says draw a grid with time on the horizontal axis numbered from 0 to 6 hours. So if you look at the horizontal axis, you see that the time is numbered from 0 to 6 hours with a scale of 2 centimeters to 1 hour. So the difference between each of them is 1. So 1, 2, 3, 4, and 5, and 6. So also the distance from home on the vertical axis. So the distance is on the vertical axis, and you're supposed to number from 0 to 120 kilometers. Then with 2 centimeters to 20 kilometers. So you add 20 to get the next one. 20 plus 20, 40, 40 plus 20, 60, and so on. So how do we plot the point? We need to take out the coordinate, the time distance coordinate. The first one is 0, 0. That's the starting point. And the next coordinate is 2 hours for the time and 120 kilometers for the distance. So a distance of 120 kilometers was covered in 2 hours. That's the line. All right. So the next coordinates, 2.5 hours and 120 kilometers. So a distance of 120 kilometers was covered in 2.5 hours. That's what is shown there. Then finally we have a distance of no distance was covered, and the total time taken for the journey is 5.5 hours. So we have this. So the most important thing here is to get the coordinates, the time distance coordinates. If you're able to get the time distance coordinates, you'll be able to draw a distance time graph as shown here. Example 2. So we're given a table of values that show the relationship between the time and distance. So we're required to draw a graph using the table of values. So you need to write out the coordinates, okay, in order for you to draw the graph. But before we draw the graph, I need you to look at the instruction given above. So it says draw a grid with time on the horizontal axis numbered from 0 to 4 hours with a scale of 1 centimeter to 30 minutes. Now, if you look at the horizontal axis, you see that we have time. But instead of having our time in hours, we have it in minutes, because the scale we are supposed to use is 1 centimeter to 30 minutes. So you change 4 hours to minutes. So that's 4 times 60. You have 240 minutes, because you're required to use the scale of 1 centimeter to 30 minutes. And you should also have the distance on the vertical axis from 0 to 40 kilometers with 1 centimeter to 5 kilometers. So the gap between each of them should be 5, 5. All right. So writing out the coordinate, the time distance coordinate for the first one, which is 0, 0, that's the point of origin. You can see the point. Then the second point, when the time is 60 minutes, a distance of 8 kilometers was covered. That's for the second point. Now the third point, a distance of 16 kilometers was covered in 120 minutes. That's what you have for the third point. And for the fourth point, you have a distance of 24 kilometers was covered in 180 minutes. Then finally, you have a distance of 32 kilometers covered in 240 minutes. So when you're done, you connect the points. You have a straight line. Okay? So you can be asked to use your graph to find the distance after 2.5 hours. Now, if you convert 2.5 hours to minutes, you have 150 minutes. So you trace it. So this is 150 minutes. To get the distance after 2.5 hours, you trace it to the distance axis. Then you have your distance to be 20 kilometers. So for the homework, you're required to do question 1 and 3. Now, just in case you're wondering what scale to use for question 1 and 3, here's a guide. For question 1, you're required to number from 0 to 5 hours on the time. Put the time on the horizontal axis and number from 0 to 5 hours. So, but you need to change your hours to minutes. So do 5 times 60, you have 300 minutes. And on the vertical axis where you have the distance, you need to number from 0 to 100 kilometers with a scale of 1 centimeter to 20 kilometers. Also for number 3, you put time on the horizontal axis, you number